Jai Hind children, welcome to today's class. In the last class, we have studied about what a relation, its domain and range. Today, we are going to study a very important concept in mathematics, that is functions. Basically, function is a special type of relation. We can see the definition. A relation from a non-empty set A to a non-empty set B is said to be a function if every element of set A has one and only one image in set B. Okay, I will give a detailed explanation for the definition of a function. The condition is that given two non-empty sets A and B, a relation from A to B is a function usually denoted with f. If the first condition is that every element of the set A, every element of the set A has a relation or can be called as mapping or can be called as correspondence, whatever it may be, has a relation or a mapping to some element of B, to some element of the set B, to some element of the set B. This is the first condition. Every element of the set A has a relation with some element of the set B. And the second condition is that this relation or connection, this relation or connection of each element in A, of each element in A, each element of A is unique. What do you mean with the term unique? Unique means one and only one. But this is the critical condition for to test whether the given relation is a function or not. Okay. At first we can go through an example and then can come to the definition again. Let A and B be two non-empty sets and let A, B and C be three elements in the set A and the set B has some elements as 1, 2, 3, 4 etc. If every element in the set A has a relation or a connection with some element of the set B, that's the first condition. Every element of the set A has a relation or a mapping to some element of the set B, and this relation or connection of each element is unique, means every element has unique image or unique mapping or has one and only one image. Function is denoted by a function f from A to B is denoted like this. Read it as function f from A to B. Here the elements 1, 2 and 3 are called the images of the elements are called the images of the elements A, B and C. Or you can say that f of A equal to 1 means that the mapping or the connection of A with F equal to 1 and the mapping or the connection of B with respect to the function F equal to 2 and F of C equal to 3. Come with the following cases. Here I marked 4 cases as case 1, case 2, case 3 and case 4. 4 situations I marked here. We can check whether the given relations are functions or not. Our condition is that at first you need to check whether every element in A has a connection with some element in B. Look at here, A has a connection with 145. Here, A represents the set of persons and B represents the height of each person. The connection from A to B is represented with or F is with respect to height. The height of A is 145 cm, the height of B is 65 cm, height of C is 125 cm and height of D is 105 cm. This means that each and every element in the set A has some connection or some relation with respect to the height in the set B. So this relation is a function, and the same way checking with the second condition, you can say that the relation of each element in the set A is unique. A has only one connection, B has only one connection, C has only one connection 125, D also has one connection 105. So two conditions satisfied in this case, hence this relation is a function. This is a function. Okay, come with case 2. Here again the set A is the set of person and the set B is the height of each person. Some numbers are given in the set B which represents the height of a person. Look at here, A is connected to 140, A is connected to 145 centimeter also. B has a connection with the 65, C to 105, D to 125 and E to 65. Checking the conditions. The first condition is that every element in the set A has some connection with the elements in B. Yes, that is correct. Every element in the set A has a connection with some element in B. So the first condition satisfies. But come to the second condition. The second condition states that the mapping or the connection of each element is unique. The element A has connection with two images 140 and 145 centimeter. Clearly you know that this is meaningless. Why? Because the height of A is 140 centimeter and the height of B is 145 centimeter. This is meaningless or impossible. Connection of each element is unique. That fails, and hence this is not a function. So the second relation is not a function. The two conditions need to satisfy for a function to be, for a relation to be a function. Come with case 3. Here A to 65, B to 65, C also to 65 and D also to 65. We need to check whether this relation is a function or not. The first condition states that every element has a relation with some element in B. Yes, that is true. But the second condition is that the connection or the relation of each element in A is unique. That is also correct. A has only one connection 65 centimeter, B has only one connection 65 centimeter, C has one connection 65 centimeter and D also has one connection 65 centimeter. That is the second condition also satisfies. Here this means that all the persons A, B, C and D have the same height. That is possible or meaningful, hence this represents a function. Here in this situation, you don't bother about some extra elements in the set B which hasn't any connection. You don't bother about that. You need to check whether the two conditions of the function satisfies or not. Come with case 4. Here A, B, C, D, E. 5 elements are the set A. The set A is the set of person and the set B represents the height of the person. As per the condition 1, every element in the set A has a connection with some element in B. Here the element E has no connection with an element in B. So the first condition fails. Hence not a function. If first condition fails, now I need to check with the second condition. Hence not a function. So what is the reason here? Here the reason is the element E in the set A has no image or no relation. So I hope that you understand how to check whether a given relation is a function or not. The two important conditions or criteria is that every element has an image. The second condition is that the image must be unique. Here two arrow marks from the same element seems to be impossible because we know that the height of a person can't be 140 and 145 centimeters simultaneously. So this is not a function. Now we can discuss with a question. Which of the following relations are functions? First question 3, 3, 4, 2, 5, 1, 6, 0 and 7, 1. Second question set 2, 0, 4, 8, 2, 1, 3, 6. For to check whether the given relation is a function or not, we can check it either through the arrow diagram or can directly write from the given relation. In the first question, from the relation you are known with, the first element in each ordered pair comes from the set A. So the set A can be marked with the elements 3, 4, 5, 6 and 7. And the second elements can be marked with the 3, 2, 1, 0, 7. 3, 2, 1, 0 and 7. So the first element comes from the set A and the second from the set B. Connecting these two elements or these two sets by means of an arrow diagram, we have 3 can be connected with the 3, 4 to 2, 5 related to 1, 6, 0 and 7, 7. Clearly from the arrow diagram it implies that the first question, the solution is, here you can say that every element in the set A has an image in set B, has an image in set B. Every element in set A has an image in set B, and the second condition is that the relation of each element in A, the relation of each element in A is unique. Each element in A, the relation of each element in A is unique. One and only one connection, hence the given relation is a function. Hence the given relation is a function. So from the first question, you can identify one more property that if the given relation is a function, the first element in each ordered pair is different. It must not repeat. The first element of each ordered pair is different, then definitely that the relation will be a function. Come with the second question. This is question number 1. I am going to write question number 2 solution. For the second question, I am going to draw an arrow diagram again. Let A and B be the two given sets in which the first element come from the set A. So 2, 4, again 2, no need to repeat it, 3. 2, 4 and 3 are the elements in the domain, and 0, 8, 1, 6. 0, 8, 1, 6 are the elements of the set B. Now we can make a connection 2 to 0, 2 to 0, 4 to 8, 2 to 1 and 3 to 6. We can check whether the given relation is a function or not, checking with the first property that every element of the set A, every element in the set A has an image in the set B, has an image in the set B. The first condition satisfies. But the second condition is that the relation of each element in A is unique, that fails. Here 2 is connected to 0 and 2 is connected to 1 also. But you need to write here the element 2 in A has two images. As which are the images? 0 and 1. Hence the given relation is not a function. Hence the given relation is not a function. Try to remember one more point from this case is that looking at the second question, you know that the second question or this relation is not a function. Why? Because the image of 2 is not unique. It has two images, that is 2, 0 and 1. From the relation itself, from the ordered pair itself or from the Cartesian product itself, you get a clear idea that in the case of the second question, the first element in each ordered pair is not different. The element 2 repeats in two ordered pairs. Hence, the given relation is not a function. When two ordered pairs have the same x element, definitely that the given relation is not a function. So, no need to draw the arrow mark. If you can directly write with the property that if each element or if the first element of each ordered pair is different, then it will be a function, and if the first element of each ordered pair is not different, then it is not a function. Now at another question. If fx equals x square plus 2x plus 3, you are given with a function as fx. Find f of 1, f of 2 and f of 3. Given fx equals x square plus 2x plus 3. You need to find f of 1 at first. F of 1 equals 1 square plus 2 into 1 plus 3. Replace all the x with 1. Then you will get f of 1. What is the value here? Which is equal to 1 square is 1 plus 2 plus 3. 3 plus 2, 5 plus 1, 6 is the answer. So, f of 1 equal to 6. In this case, you can say that the value of the function at x equal to 1 is 6. So, for to find the value of a function, you need to just substitute the value or you need to substitute the given value 1 or 2 or 3. Second, you need to find the value of the function at x equal to 2, f of 2. F of 2 means the value of the function at x equal to 2, which is equal to x square plus 2x plus 3, that can be written as 2 square plus, this is fx. So, f of 2 equals 2 square plus 2 into 2 plus 3. Replace all the x with the 2 equals 2 square is 4 plus 3, which is 11. So, you can say that the value of the function at x equal to 2 is 11. Now, you need to find one more value, f of 3. F of 3 equals, replace all the x with 3. The given function is x square plus 2x plus 3. So, what is f of 3? 3 square plus 2 into 3 plus 3 equals 3 square is 9 plus 3 2s are 6 plus 3 15 plus 3 18. So, the value of the function at x equal to 1, 2 and 3 are f of 1, f of 2 and f of 3. They are 6, 11 and 18 respectively. We are going to study domain of a function. This section seems to be very important for competitive examination too. Here in this section we are going to study about domain of real valued functions only. What do you mean with real valued functions? A real valued functions means nothing else. Both the domain and range of the function will be real numbers. That is what we call as real valued function. Both the domain and the range are a set of real numbers. That is what we mean with a real valued function. So, throughout this chapter, for all the functions, basically the domain and range are set of real numbers. Now, simply we can say that the domain of the function as the set of input values for a function. Consider a function f. From a non-empty set A to a non-empty set B. Which are the values which the function can take? They are called as the domain of the function. Consider the function as x plus 1. Here the given function is fx equal to x plus 1. So, which are the values which this function can take? And one more point, two conditions are there. One, domain means the input values of the function, and the second condition is that the input values should be valid for the function. should be valid for the function. Second condition we can check later in the coming examples. So here given function fx equal to x plus 1. Which are the values which this function can admissible? For all real numbers. For example, consider the real number 1, then another real number root 2, then another real number 1 by 2, etc. For all the real numbers, the function is valid. Why? Because f of 1 means 1 plus 1. F of root 2 means root 2 plus 1. And f of 1 by 2 means 1 by 2 plus 1. So for all the values, the function gives an output. So the domain of a function means the input values but also admissible too. Consider another function fx equals 1 by x minus 1. Now my question is that can this function admit all the real numbers? Basically real numbers are the domain of a function. Why? Because we are discussing about a real valued function. My question is that whether this function accepts all the real numbers. You may think yes, but look at the denominator. You know that if the denominator becomes equal to 0, denominator equal to 0, the function will be invalid or not defined. The function is invalid or not defined. Now my question is that which are the values which make the denominator 0? The denominator x minus 1 will become equal to 0 when x equal to 1. So when you put the value for x as 1 here, the given function becomes fx equals 1 by x minus 1 becomes, when x equal to 1 it becomes f of 1 equals 1 by 1 minus 1, which is 1 by 0, that is not defined or invalid. So among the set of real numbers, this function can't take the value 1, x equal to 1. This is not admissible for the function. So what you want to do, you need to throw away that value 1 from the given set of real numbers, which is your domain. So basically the domain of this function is the set of real numbers, but from this you need to remove the value 1, only the element 1. If you will remove, the function becomes a valid function. So I hope you understand what we mean with domain. Basically real numbers are the values in the domain, but looking at the question or given function, you need to check whether the function is valid for all the real numbers or not. If the function is invalid, you need to throw away or take off that value error. Come with another question. Here also, if the given function consists of the denominator, you need to think which are the values which make the denominator 0. We can check x square minus 8x plus 12 becomes equal to 0. When it becomes equal to 0, for to know the zeros, you have to make the linear factor method for the quadratic equation. It can be split up as x minus 6 into x minus 2 equal to 0, converting them to two linear factors, which implies x equals plus 6 and plus 2. These two values when substitute in this function, it will become equal to 0. Why? Because for example, when x equal to 6, what happens? 6 square 36 minus 6 to 8 48 plus 12 becomes equal to 0. So the values which make this function 0 or invalid are here. The values which makes the function invalid are, which are the values which make the function invalid? The numbers 2 as well as 6. We are asked to find the domain. Here the domain equals, this function can accept all real numbers except these two values that you need to throw away or to subtract or to remove from this set. So from the set of real numbers, if you subtract these two elements, the domain of the function will be valid. So this is the answer of this question. Consider another question. Square root of x minus 4. If fx equal to square root of x minus 4, find its domain. Next question. Your given function is f of x equal to root of x minus 4. Now my question is that can this function accept all the real numbers? Basically the domain consists of real numbers. Okay, we can check. I am going to substitute a value as put x equal to minus 5. X equal to minus 5. What happens to this function? When x equal to minus 5, fx will become equal to root of minus 5 minus 4, which is root of minus 9. You know that a negative root is invalid. So this function can't take the value. So when a root expression will come, you need to remember that within the root the expression should be positive or the value should be greater than or equal to 0. The value within the expression should be greater than or equal to 0. That is, greater than or equal to 0 means that 0 or positive values. Otherwise the function will become invalid. Now we can check which are the values which make this 0. That is, here the expression within the root, the expression is x minus 4. This need to be greater than or equal to 0. From this you can say that x should be greater than or equal to 4. So look at that. You can split this number line. If this is the number line R, you studied about the division of number line as intervals or subset. I am going to consider this number 4 here, 4, and your left side is minus infinity, the right side is plus infinity. They are imaginary numbers, that is not for you. So x greater than or equal to 4 means that x can take the value greater than or equal to 4. All the values from this point up to infinity is admissible for this function, because for the values lesser than 4 the function will become invalid or become negative. So what is the domain of this function? The domain of this function, infinity is a number which is imaginary. It will continue or non-stop. Hence you need to put an open bracket here. So the domain is from 4 to infinity. I hope that you understand how to find the value of a function when the expression will come within the square root. Consider another question. If fx equals 1 by root of x minus 4, then what will be its domain? Find its domain. So already you studied that two critical constraints are there. One is that if the expression has a denominator, it should not be equal to 0. And the second condition is that if the expression has a, or if the function has an expression within the square root, this expression should be greater than or equal to 0. Otherwise the function will become invalid. So these two conditions need to satisfy for the function to be valid. Here in this case, the function comes in the denominator as well as it has an expression within the root. So you need to consider the case. The function is valid only if within the root the expression x minus 4 should be greater than 0. You can't take greater than or equal to 0 here. Why? Because when within the root the expression becomes equal to 0, 1 by 0 is not defined. So if the function has a square root expression, when comes in the denominator, you must not take greater than or equal to 0, which implies x is greater than 4. X minus 4 greater than 0. The function is valid only if this x minus 4 must be positive or greater than 0, which implies x should be greater than 4. So if you take the number line R, the critical point, if you take it as 4, from 4 greater than 4 means that from 4 up to infinity you can consider all the numbers, but 4 is not included in the list and infinity also not included. So the domain of this function equal to open interval 4 and open interval infinity. It's valid when the expression within the root, that is 16 minus x square, should be greater than or equal to 0. The function is valid only when within the root the expression will be positive. But in this case, most of you may do in this way. 16 minus x square greater than or equal to 0. After this, they may write 16 greater than or equal to x square. From this, 4 greater than or equal to x. Please be very watchful that these two steps are wrong. You should not do that. It's the common mistake students are doing during the exam time. So, how to make a simplification for this type of expression? If the expression is 16 minus h square or 25 minus h square, 100 minus h square, 4 minus h square, you need to apply the property a square minus b square as a plus b in one bracket into a minus b in the other bracket. That should be greater than or equal to 0. After this step, you need to draw a number line in which minus infinity and plus infinity you can see. Now, you need to divide the real number line into separate intervals. Looking at the first bracket, which value will make the first bracket 0? When putting minus 4, the first bracket will be 0. That you need to mark the number line. Which value in the second bracket will make it 0? That is plus 4. These are the two critical values that you need to take it on the number line. Now, your number line gets divided into 3 portions. One is minus infinity minus 4, minus 4 to 4, and 4 to infinity. Now, you need to check the given function, validity of the given function in these 3 subintervals. If x lies in this interval, x minus infinity minus 4. A random value you can take among these two intervals. I am going to take a number minus 5. Minus 5 surely lies between minus infinity and minus 4. If x equal to minus 5, what happens to this function? On the right side, look at, I am going to write the expression 4 plus x into 4 minus 6. Mentally you can do this. When x equal to minus 5, what happens to this bracket? 4 plus minus 5 into 4 minus 5. You need to find the value. The ultimate sign you need to find. Here the first bracket will be negative into. The second bracket will be 4 plus 5, 9, which is positive. Negative into positive will come and the ultimate answer will be negative. So, the first bracket, your value will be negative, or in this interval, minus infinity minus 4, the function will take negative value for all the values between minus infinity and minus 4. In the same way, you need to touch with a value in the interval minus 4 to plus 4. Between minus 4 and plus 4, I am going to take a value that seems to be 0, which is comfortable for us for calculation. If x equal to 0, x equal to 0. What happens to this expression? When x equal to 0, 4 plus 0 into 4 minus 0 will come. Don't do the calculation on the upper column. You can do it mentally. 4 plus 0 is positive. 4 minus 0 also positive. So the net sign will be positive into positive. Two brackets are positive. Positive into positive, which gives positive. So among the interval minus 4 to 4, the function will take positive value. So, in this interval, minus infinity to minus 4, the function takes negative value for all the intervals or all the values, and in this interval, the function takes positive value. Now, I need to touch with the last interval. Between plus 4 and plus infinity, I am going to take a value 5. Surely 5 lies between 4 and infinity. Any value you can take, the values are random. So, if x equal to 5, what happens to the function? When x equal to 5, 4 plus 5 in one bracket into, this is your basic function, 4 plus 5 in one bracket into 4 minus 5 in the other bracket. The first bracket will be positive, the second will be negative. So, if x equal to 5, the first bracket will be positive into the second bracket will be negative. The ultimate sign will be positive into negative is negative. So, in this interval, the sign will be negative. First interval the sign is negative, the second interval the sign is positive, and the third interval the sign is negative. So now the whole interval get divided into 3 subintervals and you tested the value for each interval separately. Among these, as per our condition 4 plus x into 4 minus x greater than or equal to 0 means that positive values only will be admissible for this function. Therefore, the domain of the function is equal to, which is the domain? The domain is the set of values which make the function positive. So minus 4 to plus 4 is the domain value. Both minus 4 and plus 4 are included. A very important question. One more question of the same type we are going to discuss. Find the domain of the function. Find the domain of the function root of 64 minus x square. Once again, you are given with an expression within the square root. First of all, you need to remember that the function is valid. The function is valid when the expression within the root 64 minus x square should be greater than or equal to 0. After this, you need to write the step a square minus b square as a plus b in one bracket into a minus b in the other bracket, which is greater than or equal to 0. From this, you need to identify which are the numbers which make the bracket 0. Draw a number line. Mark the right side as plus infinity and minus infinity. Then, which value will make the first bracket 0? When putting minus 8, so that value you need to write here. And when putting plus 8, the second bracket will be 0. These are the two critical points which make the function 0. Mark them on the number line. Thus, the whole number line gets divided into 3 subintervals. Okay, I am going to take an element in this subinterval. Let it be minus 10. If x equal to minus 10, if x equals minus 10, what happens to this function? Your base function is 8 plus x into 8 minus x. When x equal to minus 10, 8 plus minus 10 into 8 minus minus 10. Now I need to do the simplification. Instead, you need to find the calculation as a plus and minus becomes minus. Both these becomes 8 plus and 18. It becomes positive. So the ultimate sign will be minus into plus, which is minus. So this interval gives the value minus. Come with another value in the second interval, minus 8 to plus 8. I am going to take a value 0, which seems easy for me. If x equal to 0, what happens to the bracket? 8 plus 0 in one bracket into 8 minus 0 in the other bracket. This becomes positive. This also becomes positive. So positive into positive, the ultimate sign is positive itself. I am going to mark that sign positive here. So in this interval, it is positive. Now, come with the value in the interval 8 to infinity. I am going to take a value as 10 between 8 and infinity. If x equal to 10, what happens? If x equals 10, we can substitute the base function 8 plus 10. This is your base function 8 plus x into 8 minus x. 8 plus 10 into 8 minus 10. 8 plus 10 positive, 8 minus 10 negative. Positive into negative, and the ultimate sign will be negative. Now you need to look at the function. Here it must be greater than or equal to 0, means that positive value only will be admissible for the function. Which subinterval gives the positive value between minus 8 and plus 8, including minus 8 and plus 8. In this interval, for all values, the function will become positive. Therefore, domain of the function equal to closed interval minus 8 plus 8.